Once again, welcome to today's class. Today, we'll be focusing on computer software. Computer software. This is like our chapter 3 of our lesson. Last class, we looked at computer hardware, and today we'll be looking at computer software, which will explore the fundamental concepts of computer software. We'll be covering the definition, the types, application, and essential rule of operating system. Okay. So when we say a software, what do we mean? Computers generally are made up of two things, what they call hardware and software. And in the last class, we understood that the hardware are the components that you can see, you can feel, and you can touch. And we saw that in the hardware, we have the input devices that are serving as hardware. We have processing devices that are serving as hardware. We have storage devices that are serving as hardware. We have output devices that are serving as hardware. Now, all these hardware that we're able to list and mention in the last class will not be able to function without a software. What then is a software? Now, a software is a collection of instructions, okay, data, or programs that operate computers and execute specific tasks. That is a software. In another form of definition, you will say a software is a set of instructions written by a programmer using a computer language in order to solve a problem. As simple as that. It is a set of instructions written by a programmer using a computer language to solve a problem. Okay? Or we can say a software is a collection of data, instructions, data or programs that operates and execute specific tasks. Now, these softwares have different types. We have them in different types. We have what we call the system software. We have what we call the application software. We have what we call the utility software. Now, to understand fully the concept of these softwares, we need to know that the computer has different languages. It has what we call the machine language. It has what we call the assembly language or low-level language. Then it has what we call the high-level language. These languages, what are they? The language of the computer is just what the computer uses to understand the instructions given to it. For instance, the machine language is a language that combines binaries of zeros and ones. So why does the computer understand zeros and ones? And why is it called binary? Because the computer is an electronic device, it uses electrical charges in order to function. So voltages or flow of current is what it uses to function. So once it is a 0, that means no voltage. Once it is the 1, which means there's a current. So it's like if you go into your room, you can switch off the light or you can put on the light, but you cannot have it in between to say whether the light is neither on nor off. Okay, you can switch on your television, you can switch it off. There is nothing like saying you are in between switching on and switching off. Okay, so it's always a two-state circuit. So by virtue of that, computers rely on binary because binary is a two-state circuit. So the machine language is made up of binary. Now, the assembly language is to simplify the binary for the use of, how do I call it? For the use of the end user. So when you say a binary, or when you say assembly language, what we are basically talking about is the concept where the computer is giving or is being issued an instruction and the computer is obeying that instruction. So the assembly language is a collection of instructions, all right? This time around, that helps to, how do I put it? Okay, when the computer programmer is building a software, the system software uses assembly language. Now, the assembly language is a low-level programming language that is closely related to the machine code. In fact, it serves as a human-readable representation of the instructions that are executed by the CPU. So, unlike the high-level language, all right, unlike the high-level language, we have different types. We have like the Python, we have the C, we have the Visual Basic, we have different high-level languages. The assembly language provides like direct control over the computer hardware. In other words, it relates directly on the computer hardware. All right, so that's why sometimes it's called low-level language, which means that it operates close to the hardware. Okay, and it has a way of reaching out or talking to the hardware, right? So that is an assembly language. In most cases, it's usually fast when it comes to execution, especially when you're talking with the hardwares. That is an assembly language, all right? Now, the other language is the high-level language, all right? The high-level language basically is the language that is being used to build application softwares. Now, in the assembly language or the low-level language, you use it to build, let's call system softwares, like operating systems and things like that. But the high-level language is designed to be easy for humans, that is for programmers, people that build applications, all right? It creates a very easy user interface and language structure for programmers to be able to write code and even understand, all right? It's abstract, complexities of the computer hardwares are taken off. In other words, the assembly language deals mostly with the computer hardwares, but the high-level language makes it easier to talk with the programmers, right? So it has human readable syntax, words that you and I will probably understand. So those are like the languages of the computer. So when you are classifying softwares, there is what we call the system softwares. And in the system softwares, it manages and controls hardwares, providing platform for application softwares. It also helps in the interconnection, communication between hardware device. If a printer wants to talk to, if a flash drive wants to talk to a printer, is the system software. If you install a mouse or a keyboard on your system and you need to talk to each other, it requires a system's software. So it relates with hardware devices. So you use the system softwares to build like operating systems. We have different operating systems. We have what we call the Windows-based operating systems. We have the Linux-based operating system. We have the Android-based operating systems. We have the Mac operating systems or the Apple OS operating systems and things like that. We have different operating systems and they are all built using the system software. Now, the other type of software is called the application software. In the application software helps users to perform specific tasks or solve problems. In fact, the application software is designed to solve a single problem, while the system software is designed to interface or create an interface between the end user and the hardware. Okay. Now, the utility softwares analyze, configures, and optimize and or maintain computer system. In most cases, we call them drivers. So maybe if I have my phone and I want to connect my phone to my system, I use a cable, then the set of instructions that will help my phone to talk well with my system is the utility software. If I connect my printer to my system, it may need to download the utility softwares for that particular printer. So most cases, the utility softwares are for external related devices. All right. So that is on those ones. Now, when you say software applications and industries, all right, we have different areas where we use computer systems and we use computer applications. One of it is the healthcare. And in the healthcare, there are specific application softwares built for that. One of it is the excuse me, is the electronic health resource software. All right. If you go to hospitals, the hospitals that are digitalized, all right, they use this EHR softwares. It is built particularly to help management of the hospitals. You have medical imaging softwares. We have telemedicine platforms. These platforms are used, like the medical imaging softwares are used to interpret maybe CT scans or X-ray or any kind of scans that are being done. All right. The telemedicine platforms are softwares that you can use to perform remote diagnosis and remote operations and things like that. So you see, in the healthcare sector, we have applications that are being used. So all these ones are application softwares. In the education sectors, you have what we call the learning management systems. There are different softwares or platforms, application softwares that you can use for learning. All right, we have a lot of them. You have Moodle, you have the ones in Google Class and things like that. You have educational apps, you have virtual classroom softwares. For instance, now we are all communicating within a virtual classroom, right? So we are using an application softwares. If you go to the area of finance, you still have accounting softwares, trading platforms, banking apps, and things like that. You can go as far as retail softwares, where you have different apps that are being used, okay? Different apps that are being used. Now, you have manufacturing industries. There are computer-aided design softwares, enterprise resource planning softwares, supply chain management softwares, and so on and so forth. If you go to the entertainment industry, you have video editing softwares, you have music production softwares, you have gaming engines. All these ones are application softwares. We have millions of application softwares down there. Now, your ability and proficiency to master a particular application software is a skill that you can say, I have a skill to play around with. Okay, so we are being advised to do that. How about operating system? You know, like we said, system softwares manage computer hardwares, they manage resources, they provide common services for computer programs. And some of the key functions of operating systems include resource process management, memory management, file management, device management, and user interface. All right, that is a very key element. Now, we have common operating systems like Windows, Mac OS, Linux, and so on and so forth. And they are all produced by different vendors. Like Windows is produced by Microsoft and widely used in personal computers and business environments. Mac OS is developed by Apple for Macintosh, okay? It's known for its sleek design, stability, and integration with other Apple products, where you talk about iPad, talk about iPhone, and the I. All right. When you talk about Linux, it's an open source operating system based on Unix. It's a popular industry to include Ubuntu, Fedora, Debian, and so on and so forth. Okay, and so forth. So for now, we're going to be doing a lot with Windows. For instance, let me show you what you can do with your Windows operating system. Okay, so right, so if I I do this, I want to believe you should be able to see my screen now. See, yes, you should be able to see. Now, with this, what you can see here is the operating system of my system performing certain analysis or processes. And what part of processes does it do? You see CPU here, it manages all the processes by the CPU. You see, these are the different processes that are currently running. This is the CPU. This is the memory, like the RAM of my system is the hardware. So the operating system that I'm having Windows now is managing this. This is the allocation. It has allocated, like this Zoom that I'm using, it has allocated 564 MB of memory, and the processor is running about 22% of my processor. If I click here, these are the different activities that is running on my Zoom. Okay, this is the disk. All right, because my disk is SSD, is extremely fast. So you see the percentage is very negligible. This is the network performance, and this is the bandwidth that I am pulling for each. So if I come to under performance here, you could see that my CPU, this is my CPU. My system is Intel Core i7. I have 2 CPUs, and it's about 2.8 gigahertz of each. You see, this is the usage. It's telling me I'm having 44% utilization. This is the speed that is running. And these are the logical processors that are being used. And these are the handlers. You see, all these details are being fetched by who? By the operating system. And the CPU, is it a hardware or a software? It's a hardware. So you see the hardware, but it's being managed by a software. If I come to memory, okay, my system has 16 gig of RAM, right? 16 gig of RAM. And so because of that, this operating system has allocated memory to different applications, and see how much memory is in use now. If I want to reduce, so I'm going to reduce some applications, and you're going to see now. So if I come to processes here, let me look at memory. Okay, the one that is being used mostly is Microsoft Edge, then desktop, then SharePoint. So let me close some of this application. You will see that the memory is going to reduce. Okay. Let me close. You will see that the memory will be reducing. This is PowerPoint. Let me see. Let me close this browser. Wow, see what different things on my browser. Let me just close this. And then you will see. So if I come to memory, can you see the graph is dropping? Can you see the graph is dropping for the memory? So each application, once you load any application to your RAM, okay, for processing, then it's been allocated. So if you have good size of RAM, then you can load a lot of applications on your browser, your system, and it's going to work. On that disk space, mine is using SSD, so it's extremely fast. So it's almost nothing. Okay, this is the Wi-Fi I'm using. Now, all these things that I'm using now is because the operating system is working. Okay, the operating system is working. It is the one that is managing all these high level devices, right? So now let's go back to our class. Where is this? Where is this? Okay, machine PowerPoint. All right. All right, so I think we're good now. So the next thing is the different operating systems. In terms of user base, All right. The Windows is more broad for home and business. All right. The Apple has its own ecosystem. The Linux is basically used by developers or enterprise or people that like for servers or for security. All right. How about the cost? The Windows, you pay for it. The Apple is free with Apple hardware. If you buy any Apple hardware, maybe iPhone or iPad or whatever, system, it comes in it. And then for Linux is a free open source, which means you don't pay for it. Okay. For customization, Windows is limited, Mac is moderate, Linux is high, which means you can customize it and play around with it the way you want it. For security, Windows is moderate, Mac is high, Linux is high. For software support, Windows has extensive support, Mac has Apple-centric support, and then for Linux, it has an open source community, right? So what are the key takeaways for what we have done today? We have seen that software is essential, which means software is the backbone of modern computing, and it enables hardware to perform their task. Okay. We've seen the different types of softwares. We have seen that we have the application software, we have the system software, we have the utility software. Then we also have a wide range of applications that works with application softwares in different industries, healthcare, and so on and so forth. Then we have the operating systems fundamentals, all right? So those are basically what we need to know about operating system, right? So I think this is where we will stop. So I'm going to pause here. If you have a question, you will raise up your electronic hand and I will give you an opportunity to ask your question. In the meantime, I'm going to also enable the attendance. Ensure that you sign in your attendance, right?